Before we start with the do now, which asks us to identify numbers, let's quickly review what we've learned so far. We know that a set is a collection of objects. We also learned different sets. Counting numbers or natural numbers is the first set that we've learned. So the counting numbers set is composed of curly brackets, 1, 2, 3, 4 ellipses, which means that it goes on forever. The whole number set, another set that we've learned earlier on, is composed of 0. That's the only element that's different. 1, 2, 3, 4 ellipses, so it goes on forever. Whole numbers, positive and negative and 0, are called integers. 0 is the middle of the set, and we go 1, 2, 3, 4, and it goes on forever on the right side. -1, -2, -3, -4 ellipses, it goes to infinity on the left side, which means it goes on forever. Then we have the rational number set, ratio, numbers that can be written as fractions, right? So the set of numbers that can be written as fractions, and that set has so many elements. We said that the set is really dense, therefore we will just describe it. It's the set of all x such that x is of the form of p over q, where p and q's are real numbers, and q must be different from 0. You can never divide by 0. Q different from 0. So 2 is really 2 over 1, so it's good. 0.333 is 1/3, so it could be written as a fraction. So we're going to conclude that non-terminating but repeating decimals are rational numbers. So they are rational, but therefore they can be written as fractions. And the last set that we're going to talk about is the set of irrational numbers, the irrational number set. And it's considered to be the set of numbers that are non-terminating and non-repeating decimal. As a matter of fact, these numbers cannot be written as fractions. Have something like 1.3256 ... That number is irrational. The square root of a non-perfect square is irrational. Square root of 2 is approximately 1.4142. Pi is the poster boy for irrational numbers, approximately 3.4 14, 15, 92, that, and also E is approximately 2.7178. So it's basically a number that cannot be written as a fraction or a ratio. Now, we will just solve the do now. We will identify the real numbers. For A it's 19, for B is negative 8109, for C rational numbers will be all the integers, and then we will add 2/3 and -1/7. And for G, which is completely separated from all of them, it's negative square root of 5, square root of 3, and